friends, I am Akshay Joe Benedict of WHS Pinwood. I have a quiz for you. Can you please tell me what's inside this box? Actually, I can give you a few clues. The first clue is that it has a very high specific heat. And the second clue is that it has high dielectric constant. And the third clue is that it is known as the universal solvent. Okay, now you might have understood what it is. Still, the fourth clue is that it has high heat of vaporization. And the fifth and the last clue is that it is known as the elixir of life. Okay, now let's see what it is. Oh, it's water. I always wonder why water is so special.
Hi friends, do you also feel that water is something special? Yes, water is special. At the very molecular level, water is different. Okay, we will discuss that today. I am Jason, your physics teacher, and you are watching me on my YouTube channel LuxNova. So let's straight dive into the topic. I said no, water is very different at the molecule level. If you ask for a one-liner explanation, this is what I must say. Water molecules have electric field around it. What's that? Water molecules have electric field around it. Now you are confused because in one of our previous lessons we studied all atoms and molecules have equal number of electrons and protons and they don't produce electric field outside the atom or molecule. But in the case of water, it is different. Let's see what is the difference with water. If you think of the chemistry of water molecule, it is H2O, something similar to carbon dioxide, CO2. See, in the case of carbon dioxide, its structure is a kind of linear structure like this. But in the case of water, H2O, this is the kind of structure we all expect. But actually that is not the case. This continues to be a linear molecule, but water is no more a linear molecule. The thing is, oxygen being highly electronegative attracts the bonded electrons towards it. So what happens is, instead of a straight molecular structure, it actually has a bend structure like this. See, oxygen here and the hydrogens are like this, and this angle is almost 105 degrees. And so a water molecule, what happens is, one side of the molecule, the oxygen side of the water molecule is slightly negatively charged and the hydrogen side is positively charged. Scientists or in science, people say this has a dipole nature. What is that? A dipole nature, or in general we say water molecule is a polar molecule. Water is a polar molecule. Now because of this polar nature, water produces or water has negative and positive charges separated slightly, or their charge centers are separated slightly, so they produce electric field in its neighborhood. It is due to this electric field water is quite unique and has lot of properties. Now this being a very important property of water molecule and lot of other molecules, what we will do is we study about this. For studying this, we make a model of two, the charges are equal of course, two equal and opposite charges separated by a distance. This kind of a setup we imagine, and we call this as electric dipole. Electric dipole. The charges are very small and the separation, in the case of water molecule where this kind of separation is large, in water molecule it's only few nanometers. So it's a very small distance. So we define dipole or electric dipole precisely like this. You have to write down it and by heart it. An electric dipole is two equal and opposite charges separated by a small distance. Whenever we talk about an electric dipole, the charges are important. So, I take the charges as plus q and minus q, and the distance between these two charges, I take it as 2a. Now, you may be wondering why I am taking it as 2a, the whole distance. Now, most often we need half of this distance, so that will comfortably a for us. So, for that we take 2a and q. So, for studying or for understanding an electric dipole, this is very important. I must tell you, this is a very exam sensitive topic. So, dear students, please listen to this remaining discussion very carefully, because it's important for us, very important for us. In an exam, usually if a larger question comes, if an essay type question comes in, you will get 5 score. At least you will get 1 or 2 scores from this topic. Now, no exam passes without a session on this. So, you should be very careful. So, whenever we are talking about the electric field of this dipole, a quantity 2aq comes very often. We call this quantity as electric dipole moment and give the symbol P, small letter P. So, this quantity is called electric dipole moment because it's very often present in electric field calculations. So, that is 2aq. So, what is electric dipole moment? The definition, you may write. Electric dipole moment is the product of this distance and charge. We call this 2a as the dipole distance and q as the charge. So, electric dipole moment is the product of dipole distance and one of the charges. If somebody asks you, once it came in the exam, what is the total charge of an electric dipole? The total charge will be minus q plus q 0. So, this is dipole moment. And can you guess its unit? Its unit will be 2a will have a unit m, meter, charge will have coulomb. So, it is, if I write mc, people may confuse it as millicoulomb. So, this should be written as cm, and you should not confuse it as centimeter because c is in capitals. Okay. And the orientation of this dipole is also important. So, we make this quantity a vector quantity. So, dipole moment is a vector quantity, and the direction we assumed for that is from minus charge to plus charge. So, this is the direction of electric dipole moment. So, you may copy that into your notebook. This is the direction to that side. Okay. If you happen to draw positive charge on this side and negative charge on that side, this is the direction of electric dipole moment. So, dipole moment direction also should be understood carefully because it comes very often in our discussions. Now, for understanding the electric field produced by this dipole, what we do is we calculate, say for example at this point, how much electric field is there by this electric dipole. What we do is we calculate the electric field at this point due to this positive charge and due to this negative charge, and we add them vectorially. Okay, superposition of electric fields. And for that, what we consider is, we consider this as a point charge. Point charge, that is another new concept in physics. Now, you cannot hold charges in air like this. You cannot have a point and charges there, but we imagine it to be there at a point. So, that is a new idea, point charge. So, what we do is, for calculating the electric field of this electric dipole, we calculate the electric field due to a point charge first. So, that calculation we will do. So, we will find out the electric field due to a point charge first. I once again reminding you, point charge is expected to be somewhere in the space. No, actually you cannot have a point charge, but it's an imagination. Like you have a point charge here. I take its magnitude to be q. We are going to find the electric field due to this charge, point charge, in its neighborhood. Say at a point here, which is at a distance say r from the position of that charge. And for finding the electric field due to this point charge, please recollect the definition of electric field. Electric field intensity, no, electric field and the term electric field intensity, we use both the terms. So, electric field intensity at this point in an electric field is the, recollect the definition, is the force on plus 1 coulomb charge kept at that point. So, you imagine plus 1 coulomb charge to be there. So, I calculate the force on that charge, and that force is the electric field intensity. So, I write electric field intensity is equal to, I use Coulomb's law for that. The equation is 1 by 4 pi epsilon 0 into Q1 Q2 by R square. So, instead of Q1 I have to substitute Q. Instead of Q2 I have to substitute 1 coulomb. So, the formula for electric field due to point charge Q is E is equal to 1 by 4 pi epsilon 0 into Q divided by R square. So, this is the formula for electric field intensity due to a point charge. This you have to by heart. This is a fundamental equation. We will be using this very often. So, you study that. Electric field intensity, don't study E is equal to 1 by 4 pi epsilon 0 into Q by R square. The equation is electric field due to a point charge Q at a distance R is E is equal to 1 by 4 pi epsilon 0 into Q divided by R square. Now, we will study this equation a bit more. This is the equation. You know, as electric field and distance, how they are related, you just see this. We usually write electric field is proportional to square of, no, electric field is proportional to 1 by R square, that is a kind of a reciprocal relationship. We call this as the inverse square law. Okay. See, this is the idea. Just imagine this electric field, this charge produces in electric field say at this point. Just imagine at a distance x, the electric field here is E. Just imagine. Can you tell me at double the distance, at twice x, how much will be E? If electric field here is E, if you double the distance here, the electric field will be E by 4 because of this R square factor. I hope you understood that. Do you still have doubt why it is E here and E by 4 here? See, this is how it happens. If R square, R is doubled, what happens is 1 by 2R the whole square will come, equal to 1 by R 4R square. That means if distance is doubled, the electric field will be 1 by 4th of the previous value. So, it is E by 4 here. Now, it is clear, no? Now, you look at this equation again. If R is infinity, electric field will be 0. And if R is 0, electric field will be infinity. See, R is 0 means you are coming closer and closer to this charge. When R is 0, you are very near to the charge or on the surface of the charge. The electric field is infinity. Don't think like that. It has no physical significance. Okay. See, what we are considering is the electric field due to this charge in the neighborhood. In such situations, this equation can be used, and the situation where R is 0 is immaterial. If you are asked to draw a graph between E and R, the graph will be something like this. Where to draw that graph? You are getting this now if I draw a graph here. So, the graph between R and E, and you can draw it to both the sides. Okay, on both the sides you can draw that. The graph will be like this. As r approaches infinity, E approaches 0, and here also. Okay, on to this side you have a symmetrical graph to the other side. So I hope this much is clear about point charges. So I hope you understood the electric field calculation of point charges. Now we continue with this. We need more space, so I am erasing this. Now we study the electric field due to an electric dipole. So you have a positive charge here, a negative charge here. Those charges are equal. So this is how we usually represent an electric dipole. This distance is 2a, means half distance will be a, and this is the direction of dipole moment P, and now you have to calculate the electric field produced by this dipole in the neighborhood. And I am once again reminding you, this is the topic very often asked in the exam. So we carefully do it. See this, and you must write along with me so that you will get more involvement in the class. Okay. Usually the electric field of 2 points are asked in the exam. These are the 2 points. This line is known as the axial line of the electric field, electric dipole, and this line which passes through the center is the equatorial line. So this is the axial line, and this is the equatorial line. You have to calculate the electric field on an axial point and on an equatorial point. So first what we will do is, we will calculate the electric field on an axial line. Okay, you may copy this into your notebook and mark a point P here. We want to calculate the electric field of that point, and that point is at a distance r from the center of the dipole. In fact, we need, see, this charge and this charge is producing electric field at this point. So you need this distance as well as this distance. I hope you understood. This distance, if this total distance is r, this much is a, so you can immediately write this distance as r minus a. Is that clear to you? And this distance you can write as r plus a. So I hope that is clear. Now we calculate the electric field intensity at this point. Now the electric field intensity here is due to positive charge and also due to the negative charge, and the positive charge is closer here, so the electric field due to this positive charge will be more and this will be less, and I am writing that E plus is equal to 1 by 4 pi epsilon 0 into q divided by this distance r minus a the whole square, and E minus is equal to 1 by 4 pi epsilon 0 into q divided by r plus a whole square. So I hope you understood these two. And this charge produces more electric field here, and it is in this direction. This is the direction of E plus, and E minus, this negative charge produces electric field in this direction. I purposefully made this line longer than this line because this is more than this one. Now the net electric field here will be the difference in these two. This is a vector addition. Remember that, not an algebraic addition, even though it appears so. So E net. The net electric field, as it is the axial line, I write it as Ex is equal to, you have to, this is more than this. So what we will do is, you have to subtract this from this. So it will be Q by 4 pi epsilon 0 into, from this I have to subtract this. So it will be 1 by r minus a whole square minus 1 by r plus a whole square. So next simplification step. I am not writing the simplification steps. You have to take this as the LCM. So that is Q divided by 4 pi epsilon 0 into, this is r minus a whole square, this is r plus a whole square. So that I can write it as r square minus a square the whole square. I hope you understood. And you have to substitute the remaining things here. You will get it as 2ar. The remaining factors will cancel out. So this is equal to, this is the equation. I can simplify that, because this distance r is usually very large compared to a. So what I do is, I consider this a to be negligibly 0. Of course this a cannot be put into 0, that will make the whole thing meaningless. So this a I am not neglecting, but this a I can neglect. So it is r square whole square, that is r raised to 4. That is cancelling with this r. So you will get it as 1 by 4 pi epsilon 0 into 2p divided by r cube. This is the equation I am getting on all axial points which are away. Okay. If the point is closer here, this is the equation you have to use. And you see a p came there, that is the p we were talking about earlier, p is 2aq. So this is the equation for electric field on the axial line. Now we go for the electric field on the equatorial line. So for that I have to write that also here. So I am erasing it here.